In part 2 of our 3-part series, I discussed testing, clearance, FDA registration, and quality of photobiomodulation devices with my guest, David Melone, manufacturer of light therapy devices for 40 years.
I want to thank you for just being open-minded enough to give it a try, right?
Yeah.
But the story you described is really the bane of my existence. It is people will use the light therapy over a broken bone, a giant wound, something like that. And they'll go to their doctor, and we hear this all the time because they report back to me, and they're like going, that my doctor's just amazed that my healing is so much faster. And they're just shocked at how good my immune system is and how well I'm healing. And they say, are you doing anything different? And in every instance, they say, LED light therapy. And the doctor says, it doesn't matter. And they will not believe it. And it's now, though, right? Now we're past it, right?
Now we're past it because lots of those doctors are referring their patients to us.
Yes.
And for so frustrated that they can't do anything for their pain or their endometriosis or whatever it is. I mean, I've gotten some really interesting referrals from physicians.
They're seeing this. Even though it's outside of their education, it's definitely outside of the pharmacopoeia that they're basically taught to prescribe. Probably one of the first energy medicines. I know that we've had lasers. Then cauterized things like that, and we have pacemakers. We have electronic devices. So I think it's coming into its own. I think it has now. I think now what I'm seeing is it's getting bigger than ever. We're also starting to see more and more devices out there and more people with different takes on the device. Like some are making a giant panel that you stand in front of. It's my understanding, it's my belief, right, that the efficacy decreases exponentially the farther away you are from it, and then you would have to greatly increase the output of that device. I know some of the handheld devices, they could be 40 watts, and I don't know if you've ever touched a 40-watt light bulb, but it will burn you, So these handheld devices have to be held off, right? Are they effective? I'm sure they're certainly effective. That's not my focus. That's not what I wanted to do. I wanted to make as dense a pad as possible and put it on the body, right? That's the whole way that we've always used.
And that it evolved, and that you saw that you observed that it was working.
Yes.
Right.
Yes.
And so, some of the fun, this has been asked to me a few times, and not so much recently, but, I've been around since the dawn of LED lights. But after we, started using the pad-based system, I've been asked by a few people, well, if they're LEDs, what makes them so special? Because my Christmas tree lights are LEDs. I mean, what, can I just wrap my body up in my Christmas tree lights? So.
It's a great question, right? Thanks for asking that, by the way. Okay, yes. Okay, you would get some benefit. You are going to get benefit. You are going to get a photon. Okay. But let's remember what really did it is multiple wavelengths of light. The depth of penetration is something we should probably discuss at this point.
Yeah, that's a good time.
Okay, so these tree lights, these LED lights, they're going to be very low in output. Infrared LEDs are measured in milliwatts per centimeter squared. And then the visible LEDs are going to be measured in luminosity, which is candle power. Okay, so those two don't actually cross over exactly, but I would say the infrared we use, they're being pulsed at about 72 milliwatts per centimeter squared, where the output of the red LEDs or the blue or whatever other color is about 5 milliwatt if you were to do the conversion, right?
Okay.
So now we talked about earlier that the wavelengths of light, that blue was cooler and red was warmer, right? Blue is a shorter wavelength and red is a longer wavelength. Blue is like 450 hertz, 450 cycles per second, and then the red is in the 650. So you got more right there, and so blue light is absorbed at the surface, goes maybe 1 or 2 millimeters. At around 600 nanometers, which would be, orangish red, they say around 11 nanometers. And then with the infrared, over 20 nanometers. It just depends on, power density, power output, and everything else. So what you're having now is you're not going to get that density. You have new devices called red light therapy. Okay.
Right.
Now this red light therapy it's not polychromatic. It doesn't have two wavelengths of light. It has a single wavelength of light. It has red LEDs,
Right.
and it's really sold and marketed and cleared for skin. Okay.
Okay.
So, it's going to be absorbed at the skin layer. Now, you're not going to get that depth of penetration we are with the infrared.
Because you're not coupling it with the infrared.
Right. You don't have that power, right? I mean, even like we mentioned earlier how we couldn't make the portable devices with the infrared because it took so much power, right? And that where the red we could use just AAA batteries and power. So you've got a longer wavelength, and you also have the more power going through it, right? So instead of 5 mils, we've got the 72 milliwatt. So I think that's a really, really big difference right there. So you're not going to, and then the other's the pulsing. Remember, the body will plateau,
Right.
you know. You also get some great benefits just by being out in the sunlight. I mean, and I think a lot of the reason this is so popular is because we're so light deficient,
Right.
So to answer the question, and I hope I did answer the question, hate to admit it, but you would get some
You will
benefit
get
out of it.
some
You would.
because light's good for us.
Light is
So
light.
even the panels
Yep.
and other things, if we're getting
100%.
right, absolutely. And so another thing that the research points to is the concentration of that high quality LED lights, those diodes in a small area that that's some of what's releasing significant amounts of nitric oxide is the concentration of how many. That one pad that you held up before, 132 diodes.
Yes,
The
exactly.
bigger one is 264 diodes. Okay, and so we're getting, and then against the skin, it's really doing its thing.
Let's talk about that density of those diodes. How did that come about,
Yeah.
right? So we progressed on making a pad with 50 LEDs in it. Now, remember I talked about Dan Paris's cluster probe. This is 30 LEDs in a 2-inch diameter. I've got 50 LEDs in an 8x5 pad, right? Fantastic results. But some of the doctors, nurse practitioners were saying, we noticed that with the probe that we're getting better results, right? Now, the probe was actually held off the skin by about this far too. It had a little glass lens on it, but had a lot of power, a lot of density. And they're like, could you, in a flexible pad, increase it? At the time, as you can see, I'm just going to hold this one up. I'm going to turn that off for a moment. So we've got the infrared, we've got the red. I had rows of infrared, red, infrared, and all I did was just slide them into each other. So I would, and it just doubled the density. So instead of 50 LEDs, I put 90 LEDs in a pad in the same size area.
Okay.
And so, and that once again, an absolute huge breakthrough.
Right.
And then, of course, we go on, and now these devices have been used by there's thousands and tens of thousands, if not hundreds of thousands of them out there at this point. So people come to me, they go, could you make an even larger pad? Well, yes, I can, but I needed forward and backward compatibility. I wanted you to be able to take this larger pad and plug it into a device that was 10 years old or 5 years old, or a new device. So figured out how to do that, figured out how to add more LEDs into it. And that's where we have now. So now our largest one is 264 LEDs. Some companies use area-specific devices that are only good for here, only good for there. I wanted this to be good for the whole family. I really was trying to manufacture a device that was a family, that was a home device, not necessarily that you had to go to the doctor and use. I had been using this my whole life at home, right? I knew the benefits of home use.
Right.
So that's what I was manufacturing. So I went with generic shapes. I went with rectangular shape that would cover a large area. just different, than others, and stuck with that. I mean, we have different shaped pads and caps and things like that, but that's really how that density came about. And I have not changed the energy density or the power output of these in at least 10 years. It was originally a 30-minute treatment. When we got the newer LEDs 10, 15 years ago, I don't remember exactly when now, we realized we could go from a 30-minute treatment down to a 20-minute treatment. And I'll be honest with you, we actually got great results at 15 minutes. But people didn't believe that 15 minutes was enough. They didn't feel it. They felt like that was too short of a time. It was a real complaint. They said, people don't feel like they got anything at just 15 minutes, even though they did get the same dosage of light, right? So we increased it to 20 minutes. 20 minutes is where we've been. I think that's a great dosage. There are devices out there that that'll treat an area in a minute and a half. That's great. They use a lot more power. Once again, I haven't seen the research to say how quickly the body can absorb it. What is too much? What is oversaturation? Right? So this is my experience. This is what we've seen, and I believe that this is optimal. And I think a lot of other people do too, because
Yeah, well, you've sold hundreds of thousands of
hundreds of
units.
thousands, and there's a lot of devices that are extremely similar to mine with almost the exact same energy density. So I think that we hit on the key, right?
You have been
You
knocked
know,
off a few times.
I gotta say, Ginger and I, we did a little talk yesterday, and we had a woman that was kind of usurping the conversation, right?
Right.
She really wanted to get in, and she had a couple questions for me, right? She's like, okay, if you've done this for 40 years, why haven't we heard about you? Okay. And then she said, where's your science? And that's when, I said to her, I said, well, what is science? Science is observation. So, I mean, if I'm not the scientist behind it, even though I'm not technically a scientist, didn't go to school for that, but for 40 years, we've observed, we have tweaked, we have modified, we've experimented, we've changed, right? And now we're here. And why don't they know about me? Okay, well, as a device manufacturer, I'm not the doctor, and I'm also not the star of this, okay? LED light therapy is the star. I stood in the background. I was very happy to be in the background,
Right.
and let the device speak for itself, I think now we're to a point, well, okay, and part of that was because we didn't get into the Food and Drug Administration. So the Food and Drug Administration, the FDA, are in charge of all things that you ingest, including light, energy medicine, anything that modifies or changes the body. That is their purview. You have to listen to them and do what they say, and they're there for a reason, right? They're there to protect us, right? They are our friends.
Correct.
Okay, okay. So at that point, it wasn't up to me. I'm not a doctor. I was not allowed and couldn't say, I can't practice medicine. I'm not going to tell a doctor how to use this device. Okay? I waited for the doctors to tell us how to use this device. Now, how did I get clearance for it? And that's what you have to have, right? Um, you need to have clearance to be able to market a device. So the you must do all your paperwork and you must submit everything to the FDA, and then they decide whether it's safe and efficacious and whether it can be brought to market, right? Now, to do that, we needed Gerald Ford, 1976, he signs the Device Act, and now all of a sudden, electronic devices are going to be under the FDA. Okay, so now we've recognized them. This is a huge step forward. We've now recognized that these devices do make a change. So, really big step. At the same time, we must now, I don't remember what year they came out with the 510K, but a 510K is basically, it's you're going to manufacture an experimental device, right? And so and you're allowed to manufacture, I don't know how many thousands of these experimental devices until hopefully it comes to a point where it's no longer experimental. And at that point, now the 510K process is a very onerous process. You have to really go through a lot to get it.
It's very expensive.
Extremely expensive, requiring, FDA consultants and, um, The first one I know that we applied for was about 125 pages. By the time we go back in around 2000, I forgot the year, it's over 500 pages, documenting everything. And another one is electrical testing. There's regulatory testing services. One of them you've probably heard of, I think we've heard of it most of our lives, UL, Underwriters Laboratory, independent laboratory that tests these devices. You tell them what you think it does, what its output is. They test it and they certify it that it does that. Okay. There's other ones. There's ones all over the world now.
Another expensive process.
Another extremely expensive, time-consuming process.
Yeah.
But when we went through, okay.
Right.
Another one I've had people. We talked earlier about infrared light. We've had people say it could damage the eye. First of all, we're getting infrared light off the sun all day long, right? I mean, infrared has been around. We didn't invent infrared. Infrared was discovered, right? Wasn't invented. During the UL testing, one of the things they do is they test it for if it'll harm you or not, and that is the entire body, including the eyes. And they do multiple tests, and there's multiple pages in the 510K, which is the document that show that it's safe and effective. So I think that answers that question. I have that question a lot, and that's usually what I do is it just absolutely explain to them that it was UL tested, and it doesn't damage the eyes. So,
Right.
so I just wanted to get that point out.
Yeah, so now with the new registration, because you've gone through all that, and and you've been doing this for 40 years, and NASA has been studying light therapy for decades, and Harvard and University of Colorado, et cetera, et cetera. And now, huge organizations studying all this, but maybe not for 40 years, maybe some of them. I mean, I know when the twins were born, they were put under blue light. So, we've been using some form of light therapy in the hospitals and whatever for a while, but not mainstream like it is now. So there's a lot of products now that are just all of a sudden flooding the market. And again, I'm going to say we're for anything that helps a person have a better life. And there's lots of great products out there. I mean, obviously, I'm prejudiced about your product because it's what we've personally used for all these years. But what do you think about like I'll have people ask me my opinion. They'll bring products to my office that look similar to your products, and I'm not a electrical person. It's like I can say, well, it looks similar, but I have also had people say, well, I went off and I bought something and it was, a lot less money, but now it fell apart or it lit on fire or whatever. So, I mean, what's the difference? I mean, how do you explain that?
I'm glad I got to go through the entire process, right? From the beginning to where we're at now, to see 1 milliwatt affect a change and see how it's grown and how it's changed. I think the 510K was fantastic, right? Very difficult, very hard. I would have not said this
Right.
at the beginning of the 510K process, right?
Clearly.
But it did what it did do due to that, and that is the beauty of the FDA, is they made sure they regulated it was safe and effective while it was experimental. Now that they've found that it is safe and effective, they removed that. So now you don't have to jump through all the hoops.
Right.
You don't have to have it tested, right? And I think because of that, a lot of times you're not going to know what you're getting. It wasn't, like I said, it wasn't tested, and devices can fail. They can catch fire. A lot of things can happen on that. Plus, it also paves the way for someone just to manufacture some that just heard about it and want to get into the market without any experience or really any education or knowing what they're doing. They're just riding the wave, and they're going to make another low, inexpensive LED light therapy product. And I think part of that has kind of flooded the market with a lot of stuff that is inferior, low quality. It kind of gives the product a bad name. I mean, if you buy a product, and even if it helps you, if it falls apart, very quickly, it's gonna taint you. You may not go back to it, right? The product we make, the LEDs we made, or make. The lifespan is about 100,000 hours on them. Now, we pulse them at a 50% duty cycle, which means that extends that life cycle to 200,000 hours. 200,000 hours on a device that at most, even in a clinical setting, would be used 8 hours a day. I've never personally myself seen one of these LEDs burn out. Now, mechanical failures, absolutely, but not burnout. These LEDs, we repair pads that are 10 years old.
Yeah, I know you've
Yeah.
repaired some of my
Yeah, I
10-year-old
mean
pads.
the way we make the device, is we put the this is the soft neoprene, the flexible diameter neoprene, much more comfortable than that rigid piece. It's like tire rubber is what we started with, but that's what we had available.
Right.
You know, I mean, really, I grew up with this and grew up with electronics. You know,
Right.
growing. Dan Paris bought the first transistor in Tulsa, Oklahoma. He was working for a company and they sent him to buy the first one. He paid $100 for a transistor. They were brand new, right? I mean, they'd been around for a while, but they were revolutionary. They really changed everything. It changed electronics, right? But I remember about 10 years later, one day I'm talking to him. I said, "Hey, I just bought 1,000 of them for $20." And he was like, "You did not." And I said, "Yes, I did." And I show him to him, and he's like, "Oh my God." And I said, "Yeah, they've really come down." Now transistors, right? Our computer chips are all transistors, okay? To me, transistor is very similar to a neuron in the brain, right? It opens and allows current through, right? Allows signals through, just like a neuron does, you know? So now a computer chip can have, in a little wafer, it can have, you know, 1,000,000 transistors, you know. There's a Dr. Moore in the 60s kept looking at it. He wrote a thing called Moore's Law. And about Moore's Law says that the amount of transistors, I'm paraphrasing here, on a substrate will double approximately every 1.5 to 2 years. And that law is held steady now for up until now. So now you can have 30 million, 40 million transistors in a chip, right? In a few years, and we may already be there, 100 million. You multiply 10 years down the road, 5 more generations, and now we've got something with 10 times the neurons that the human brain has. I mean, things are changing very, very rapidly. It's amazing
The world is
to me.
changing,
The
right?
world is changing, you know. So it's just, once again, to grow up with it, to watch it, to see it, you know, and now to see where we're going, you know, I envision this product. If we take this all the way into the future, the product that I would make, and I probably shouldn't say it, but I'm going to, I may not be here for it, right? Transistors now are infinitesimally small. They are 7 nanometers, 4 nanometers. At some point, we won't be able to make them any smaller. Okay, then we'll have to stack them in order to keep growing, but we'll find a way. You know, we will always find a way. What would it take? What does it take to make this device? We need a power source. We need a light source. Okay, we need the knowledge that we have of frequencies and light. Right. So how small can we make it? I mean, I envision it being so small that it can be injected into the body, right? Powered by, you know, piezoelectric, just by movement. There's so many ways you could power it. You know, now of course we have all different kinds. You know, we have inductive charging that we could do. So you don't even have to have it on the body. Pacemakers now are inductively charged. You don't have to remove them, put a battery in. You just put a device over it and you recharge the pacemaker, right? So I envision these being put into the body, having a program in them, right, that is looking for areas that need circulation, areas that need treatment, maybe even ablation, right? I mean, if we can heal, we can kill, right? I mean, so if we can light it up or we could burn it out, I mean, so we could find bad cells and we could, you know, eliminate them, or we could energize the good cells. So I think in the future, these devices will basically be floating around inside of us and greatly extend our life, you know? I mean, we've seen improvement in everything.
Ginger Bowler has a doctorate in energy medicine and is a certified light therapy instructor, biofeedback instructor, and co-founder of the Light Energy Training Seminars certification program. You can send us an email with your questions and comments to podcast@letskeepitlight.com. And be sure to visit us on Facebook, YouTube, and Instagram. And remember, let's keep it light.